Okay, so I'm running a little late tonight, so I just gotta get myself into a space where we can do some programming. Um, might as well reflect on day three. Uh, here we go. So, what did we learn from day three? Let's format this a little better. Okay. Um, well, I'm surprised that just 3 days in, we've already gotten to some puzzles that where thinking is useful. I mean, particularly the second part of day three. I think if I had taken a minute or two to kind of step back and think through what I was doing, it probably would have gone faster. And I had thought in previous years it took until the end of the first week for that to happen. But so that's a good kind of check on myself. Sorry, I'm paranoid about the time. Um, in terms of the code we wrote yesterday, I mean, one kind of obvious bit of stupidity. I spent a little time just putting this array literal together. There is a constructor to do exactly that, an initializer in Swift to do exactly that, and it's the repeating count initializer. So really, that's what I should have used there because it's more clear, and then you know exactly how many you're creating, and yada yada yada. Um, there, I had the thought while doing this, although I didn't say anything, I could have used a dictionary instead and used integers as the keys instead of using an array where you can use integers as the keys. I'm not going to dwell right now on the situations in which that is better or worse. It's obviously more general in some ways, but completely unnecessary for yesterday's. Um, but the thought I had while looking at that was that I wasn't actually sure the most efficient way to create such an array in a one-liner. And the big thing was you can't just give it a sequence of tuples. There's a name for that parameter, and I don't know the name from memory, but it is unique keys with value. So you can make a dictionary from int to int. Um, and then you do this range, and then you map it, and you get all the zeros, and that gets us the dictionary that would have performed equivalently to the array that we actually made. Um, I suppose there are interesting things to say about that API. I mean, it looks like exactly the reason Swift is so annoying for doing these programming contests because it's quite wordy. Um, but on the other hand, it's very good API design because there is a nuance to building a dictionary from a sequence. Because what happens if you have non-unique keys, and this API forces you to think about that. So I'm very for this API structure. It does take more characters. We have a minute left. What else can we talk about? Also, yesterday, you'll note I did use cut and paste reuse yesterday. These two blocks are identical. Again, I don't have the time to really go into when cut and paste reuse is useful. I think in programming contests it's not inappropriate, but you really should make sure that the first version works before you cut and paste, because otherwise you end up editing multiple times, which I did yesterday. So we should learn that. Um, would a function with a let's not bother dwelling on the rest of this stuff right now because we only have 20 seconds left and I haven't really touched a computer today, so I'm not feeling super confident right now. So the first part will probably ease me back into feeling like I remember how to program. So let's see what day four has in store for us. Bingo. Oh my. Okay. Well, let's just get these lines. This is non-uniform input, right? So let's get our input. Right, so we have one magic line and then a bunch of records separated by blank lines, and I don't want to do that. Let's just cat it. Right. Okay. Okay, so we have our input here. Let's not map it. Okay, so let header is the 0th line. Split on comma map. Okay, let's see if this works. Just to do our first piece of parsing. Oh no, come on, where's my, there we go. Oh, what? Lines. I'm kind of an idiot. Okay. What? Why am I already doing dumb things? Okay. That looks good to me. Yeah, listen, we can get rid of this. Sorry. Okay, so we got our header, and I think that's the format we're going to want. So, okay, block. So we're going to read each one of these bingo cards, I guess, into what I'm calling a block. So in data, and we will skip actually the first 2 lines because the blank line is there. Yeah. And okay, so if that, we're going to actually process the block. Let's actually say we print the block for now. And otherwise, okay, so how does that go? I think I'm going to have to do something special for my last block. Oh, we've already done something. Expression and list of expressions in 12. Oh, print. What? Okay. What? Append. What? Come on, how do you tack onto the end of an array? I should know this. What? Why do I not know how to append? Adding and removing elements. Append. It's append. Okay, what was the error? Candidate. Oh, it expects a string, and these are all... This stupid string versus substring thing is just super annoying in Swift. No. What? That's on line 3rd. Oh, God, I put it in the wrong place. Oh, Rob is not a brilliant man. And we still are not getting this. Initializer, print string. Yeah. What a waste. So we never printed any blocks. That's odd. If I could have used a guard statement here, actually, which is a little more elegant, but so why? So there are no blank. Oh, because I think we actually have new lines in there, don't we? So now what happens? No. Okay, let's actually just print each one. For data equals lines, we're gonna have to go to our no. Oh. Open. Input. So what is lines? Split separator. Yeah. Oh, of course, because it's emitting the completely blank ones. So let's do this. If you don't set this emitting empty subsequences thing, then it emits empty subsequences. Surprisingly enough. So what happens now? Did I get the syntax right? No, of course I didn't. Oh, of course I didn't. Oh. File. Okay, so something is happening there. Let's get rid of our superfluous print and see if we can actually get blocks to print. But I think it's actually blank lines because we split on the other thing. So we are getting that. Okay, that's good. Except it's a giant thing. Oh, so when we do this, to reset the block to nothing. And so what should we do? Block append. So L is a line here, and we are going to split it on spaces. And we're going to intify it again, right? So let's see what that looks like. No. Oh, because block. Let's make it an array of ints. Is that working? No, it's not. But it's a more interesting. Cannot convert values. Oh, no, sorry. Fatal error. Found nil. Eesh. Is it because we got these and stupid? Do we have a strip function? Yes, we do have a strip function that I wrote, don't we? So no, I wrote a strip function, didn't I? Stripped, and it does, and it removes the beginning and end. So let's go down here and does that fix it, or are we still no? Sigh. Okay, we can't do this with a map, so 4. Because I think we're actually getting empty strings in our split. Do I have a split? Well, I don't know if I have a split that actually coalesces all white space. If S. Okay, does that work? And then we can say block. I'm a shockingly bad programmer. Yeah. Now, what didn't work? Cannot increment. That's all a bit of a shame. Really, so my strip function doesn't work? So how many spaces do we have? And S is not equal to a space. And S is not equal to 2 spaces. And S is not equal to... I don't think we need this third one, but... I think that's a positive. So... block. So now, let's see what we have here. If we print the blocks before clearing them. And I said I needed to do something about our last block, because our last block is 1475, 2242, 2. Oh, it did work because I did put a new line at the end. Sometimes the input doesn't have that. Okay, so we have marshaled our data in some way. I still have no idea what we're doing with it. Okay, the score of the winning board. So the numbers are called in the first line. Okay, so we have boards. Array of ints? Yeah. Ooh, this is going to get very confusing. So okay, so we built up a collection of boards. And we want to say whether a board wins, right? So, there's a set in Swift, isn't there? Is it just called set? Anyway, board is no, and the called numbers is set at the end of the thing. Let's just make sure it is, because I don't remember sets very much in Swift. Check it. Compiles. It does compile. So apparently there is a set. Okay, so okay. And what do we do? Horizontal, vertical, and bingo is marked on all board numbers, full numbers, in any row or any column. Oh, no diagonals, which makes it a lot easier. So, okay. So, if let's a labeled break is really what we want, isn't it? How do you do a labeled break in Swift? It's just like that. Let's see if it works. For row, if okay. So that seems like the logic to check whether a row wins, and it compiles, which is always a nice one. So, now to check the columns. Which column, and then we have to go through all the rows for row. I don't know, does this compile? Oh, we haven't actually called this thing yet. So, for is it insert? Let's just check if that's the correct function. It's oh, that's fine. But it looks like it is insert. If wins is what board then called? Oh, and I never stopped, did I? So, when did we first win? Come on, baby. So, somebody won at 42. Okay, that sounds reasonable. After, at this point, wins. The score is start by finding the sum of all unmarked numbers on that board, multiply the number that was just called. Okay, so let's actually do this here. So if it wins, okay, yeah, come on. So for that's over the rows. So now we have the total of unmarked. Then multiply that by number that's just called. So print the total times n. I'm masking variables in a slightly confusing way here. And then let's break our outer loop. Okay, do we have a solution? Well, maybe. Drats. Okay. So let's use the test data. So let's just run it with this data and see if anything catastrophic happens. We get 4512. Wait, I got the right answer on that. Guarantee. Figure out which board will win first. What will your final score be if you choose that board? Okay, so maybe the example only does rows, so maybe I got my columns wrong, as a possibility. I think my scoring function seems to be working correctly. Figure out which board. Okay, let's actually not. What is this? Let's not stop when we do this, and let's just make sure that we sometimes So on our test data, we get row wins, which makes sense. Why does the score go down? Oh, because the last drawn number can make it higher. Okay, so that all seems reasonable. Now let's go back to our real data. Obviously, if you don't get it right, you're not going to hit the leaderboard. So row win. I am getting call wins. Yeah. So it's not crazy. It's one complete row. Entire top row. The score. Figure out which board will win first. What will your final score be if you choose that board? I am a little annoyed that we didn't get this. 26775. Sum of all unmarked numbers. Well, I don't really know where to go looking for this bug. Let's at this point, let's print the board and what's called. See if there's anything obvious here. So we're saying it was a column victory. Let me see. Array of int of called. Just because I want these to be in order. Okay. Call win. When we get a call win, let's say I want to know which column. Tell me which column won. Okay, so we do have a 6. Do we have a 58? Yes. We have a 51. Yes. Have a 12. Yes. Have a 15. Yes. 1, 2, 3, 4, 5. Yeah. Start by finding the sum of all unmarked numbers. Well, I'm at a loss. Chosen marked. So the question is, could someone else have won first, and we've selected the wrong board because we missed someone else winning? Because this looks like a win. Well, we might as well. I thought it was good. So total is 525, which seems reasonable. 51 was just called. score will be if you choose that board. And then let's just make sure we understood what our header is. First five numbers are 7, 4, 9, 5, 11. Yeah, that seems right. Well, I'm not really sure, so let's add a few assertions just to make sure that everything is working out. Um, Let's actually just say so we're just making sure all our boards are actually the right shape. Looks like they all are. Is there anything interesting about these numbers? I mean, 0 exists. Am I handling 0 badly? 0 is in there before the 42nd number, but I'm not doing anything terribly interesting with it. What was our winning board? Just 691.56. 691.56. Oh, what am I doing? 691.56. So this is the board that we win, and it's the first column there. And that all looks good. Yeah. Well, it's not great. So mean, there are a lot of these. Let's, so, that's what we said was our first win. Did someone else win at the exact same time? No, because that has one more number in it, doesn't it? So, sorry, this has one more number in it the second time through. So no one else did win at the same time. This is a disaster. Really, and the test data works. I hate it when the test data works, but the real stuff doesn't. And let's actually put our break back in there. Oh, yeah. Don't send it to output. 28, 24, 45, 12. I just don't know. Sum of all numbers. Multiply with the number that was just called. Figure out which board will win first. What will your score be? Choose that board. I just don't get it. And just to be, let's just make sure that we really did capture all this. 1745, 73, yeah. And 1475, 22, 42, 2. We got all the boards. And we did check it, right? But I kind of suspected that was the case. Yeah. So read all the boards. just want to make sure that we actually did capture that. Yeah, 22, 42, 2. So we did get all, we read all the boards incorrectly, I think. I mean, I don't think that's a thing, but wait. Oh, really? The shadowing rules were we were changing n? Oh, that is yeah. Oh, oh. It's not that. But it is incredibly troubling that that did it because it means I'm not right about what the shadowing rules are. Um, so for row. To- ah, I might have been right and then I just made it all wrong. So, see. Yeah, we're back to our original number. So renaming that variable didn't actually change anything. Renaming it incorrectly did. Um, I think my scoring rule is good. So draw one. $26,775. It's so 51. So how far do we get in the yeah, the last number was 51. So that takes us to there. I mean, we can guess the same number again. Maybe I copied it wrongly the first time. 26775. Really? We're gonna submit a third wrong answer just because we didn't believe we plugged it in the right the first time. We're 45 minutes into this. This is ridiculous. Well, We must be missing a board that wins earlier, right? So, our wins routine. Not called. Oh, these aren't breaks, they're continues, aren't they? Oh, sigh. 45 minutes to realize that. 2496. Oh, what are we doing? Is this test data input 2496? We think that's it. Okay. Okay. On to part 2. To figure out which board will win last. Okay, so let's how do we do this? Set haven't won. Yeah. So let's say let's keep track of the boards that haven't won. Let's say that's a set of boards. Right? That seems reasonable. But actually, we will first build all of our boards, right? And then we'll say, God, what was, this was our introduction. Unique with keys or some crap like that, of the boards, right? Oh, actually, no, it's just set. I don't even know what the set constructor is. That can just take a sequence, can it? Can it? Sure. Okay. So haven't won. And, okay, if it wins, haven't won, remove. Okay, and we don't break our outer loop when this happens. If one contains and so in this case we will, so it's just the last thing we print. The reason we can't just take the last thing without keeping track of the haven't won. I don't want to explain everything as I go. Let's just see if this is the right answer, and then I can give brilliant thoughts. Yeah, okay. So Um, we could have just let the original code run, and we would have seen the last thing to win. But boards would have kept winning on every single iteration, because once they've won, then they win in every subsequent thing. And what's more, that the way they're scored changes. So yeah, so what we want is the first time the last one wins. And we want to just print things the first time they win. So that's how we've changed the code. We've now made it so that we only print a board the first time it wins. Right? That's what this hasn't won guard does. I mean, the immediate retrospective here is I used break where I meant continue. And, you know, well, let's look at that a little more closely. Where was that? So right here. So what I was doing was I was saying, well, once we've realized that a row, that there was something in a row that hadn't been called yet. What I meant to say was let's give up on the row. What I actually said was let's give up on all rows. So that's a shame. And I did the same thing for columns. And it took me a really long time to figure that out. I guess we can think about what would a better debugging strategy have been. The trouble is it's hard to hand check these yeah. I mean, more test data would have helped, but anyway. Well, we got them both. Let's see what our standings are. Yes, well, that will happen when you have to do a whole bunch of debugging. It's unfortunate, but it is what it is. Anyway, thanks for watching. I started a little late tonight, so I'll finish the retrospective on day 3 and do a day 4 retrospective tomorrow. So I'll see you then.